Today what we're going to do is find the area of composite figures. So we're going to take a lot of different polygons, different shapes we've been looking at, and we are going to combine them together to make more interesting shapes and then find their area. Why might you need to do that? Well, in real life, if you were carpeting a floor, it's not as if every floor is square or rectangular, or even circular. That'd be a cool floor. Same thing too when you're buying paint and you want to, paint a certain surface area of the walls. You're not necessarily painting every facet of the wall itself because you might have windows, you might have, borders around the windows and other things that, would be spaces you wouldn't paint. So this will be kind of fun, and it's basically just a lot of practice. First thing we should do, though, is remind ourselves of the different area formulas that we have already learned. So let's go ahead and just remember that a parallelogram, its area is equal to base times height. And remember that with a parallelogram, the opposite sides are parallel and the opposite sides are also equal. So, yes, it includes slanted shapes. That's a very poor parallelogram. But that also includes squares and rectangles. So just keep that in mind. Triangles are half the base times the height. And you might have a right triangle, you might have not a right triangle, maybe an obtuse triangle or an acute triangle. Let's see, what would that look like? Maybe an equilateral triangle, something like that. Trapezoids, their formula is a little bit more intricate. So I do recommend, making sure that you write it down before you go ahead and use it, just to make sure it's accurate. So half height times the sum of the bases, base 1 plus base 2. In the book, I think they just say A plus B, but that represents one base and the other base. Remember, the bases have to be parallel. So the bases are parallel to each other. And the height is perpendicular. That means it forms a right angle with the bases. That's just to help you identify what the bases happen to be in the shape and what the height happens to be. And then, of course, a circle is pi r squared. And remember that if you have a semicircle, you just need to take half that. So pi r squared over 2 if you have a semicircle. So let's just go ahead and take a look at the handout and practice some of those problems because they have some neat pictures there. So if we take a look at page 56, just starting with number 1. Again, please bear with me with my drawing. It is a little bit more messy using this device, so it's not as clean. It looks something like this. Okay, so of course we have everything labeled 8 miles, 3 miles. Remember, mi is miles and m is meters. 2 miles, 6 miles, so this is a large area. 10 miles, and then we have some other labels to make 4 miles here, and whoop, that is 2 miles. We need to find the area of each figure and round to the nearest tenth if necessary. So in this shape, the first thing I would notice is that I have basically a bunch of rectangles, of parallelograms. And you need to use the information that you're given to figure out missing lengths. So, it might be helpful to divide rectangles up like this, or it might be more helpful to divide them up like this. It will just depend on, what we're given and what we have. Right away, if I'm looking at this top parallelogram or rectangle, I do notice that I'm given its base and height. So I could find that area right away by doing 8 times 3. And 8 times 3 gives us 24 square miles. Okay, so that's this area here. Okay, so what else are we trying to find? Well, if I look at the bottom, I see again that I have another base and height of this bottom rectangle. So 6 times 2, and that gives me 12 square miles. Okay, so that's covered. So what's left? Well, this little kind of rectangle parallelogram in the middle here, and it'd be really nice if we knew its base and height. Well, right now, just looking at this, we do not have those measurements. I know the length of this entire side, and I know little bits and pieces, like this is 2 miles and this is 4 miles, but I will need to use other information to figure out what this base and width happen to be. So again, I'm looking for this base and this height. So what do I know? Well, I know this whole side is 10 miles. I know this is 3, and I know this is 6. So if I take away the 6 and the 3, I will get this measurement. So 10 minus 3 minus 6. Whoops, I wrote down the wrong measurement. I'm sorry, because that doesn't make any sense. And that's good to do. If you always do something, you're like, wait a second, 1 mile, that really doesn't fit with my picture. Go back and check your work. So, sorry, this is 3 miles here, and this is 2 miles. So let's rework that. 10 minus 3 minus 2. That looks a little bit better. 5 miles. And let's go ahead and see if we can figure out this measurement here. I know that this entire side is 6 miles and that this little piece right here is 2. So if I take away those 2 miles, I will get that measurement. So 6 minus 2 will give me 4 miles. I can go ahead and multiply those together because now I have my base times my height, and I can get 20 square miles. And then, in order to get the total area, I just have to add all of these together. So what will that give me? 20, 30, 40, 50, 56 square miles. And that's the idea here. You just need to break it apart. If you break something apart and you're unable to find a missing piece, then maybe you just need to break it apart into a different shape, or just take another look at it. How else can you use the information you have given? Because you'll always have enough information with these problems to find the shaded area. Let's go ahead and take a look at another one on the same page. In fact, how about, oops, you go ahead and try number 2. That will be pretty fun. So try this one on your own and hit unpause when you're ready to see the solution. Okay, I've actually done it all out here so you can just check yourself. Here we have 2 trapezoids and 2 rectangles. I figured out the area of one of the trapezoids first using that height of 9 millimeters and its base is 10 millimeters and 20 millimeters. And I recognized that I had 2 of the same shape, so I can multiply those by 2 to get an area of 270 millimeters squared just for my trapezoids. My long skinny rectangle, this is one where I'm not given its base. I have to figure it out using the information given. So I know that this length is 10 millimeters. This is 3 and this is also 3. So 10 minus 3 minus 3 gives me 4 millimeters. I know the height is 20 millimeters. So 40 times 20 is 80 millimeters. And then the smaller rectangle, 10 times 5 gives you 50 millimeters. I add them up together and you get 400 millimeters. I would just like you to do a few more practice problems on your own, and then I'll just give you the solutions for you to check yourself. Please do number 3. There's a half circle there. That would be fun to work with. Number 4, we'll say number 11 and number 12. Those are kind of fun. And then we will work on a lot more of these in class tomorrow. So again, hit pause, work on those, and hit unpause when you're ready to see the solutions. Okay, so for number 3, you should get 84 square feet. For number 4, you should get 237.1 square meters. For number 11, you should have gotten the shaded area of being 84 inches squared. The cool thing with these shapes is that you have to figure out the area of the non-shaded portions and then subtract them from the whole, so that you find out what just the shaded area happens to be. And you think you were just working with all parallelograms with number 11. And in number 12, you have, a couple half circles and then some cones on the inside that are fun to work with. You should get 66.8 square yards. Okay, just double check yourself if something wasn't quite right. I don't think I mentioned before, but it will be fine for you to use a calculator to make these calculations in order to save time, because I'd like you to focus more on the process of how to work through these types of problems than on just the multiplication. Okay, thank you. Bye.